for joining us today for our webinar, AI-Powered Code Refactoring. I'm Steve Collins, Director of Professional Services here at LANSA, and I'm joined by Nick Hall, who is the architect of our exciting new AI product. We'll be getting started in just a couple minutes, so maybe it's a good time to stretch your legs, grab a tea or coffee, and we'll kick it off shortly. Okay, I'm getting the signal here that we've got lots of attendees and we should get going. So let's do that. Once again, everybody, welcome. We will have the questions panel open. So you should see somewhere in your interface that there's a questions area. You can click on there, add your questions as they come to mind, and we'll answer them at the end of the session. Okay. So this webinar is about how AI can help our customers with legacy LANSA apps quickly and cheaply get to a MACH architecture. MACH stands for microservices, API first, cloud native, and headless. It's kind of where everybody wants to be these days in a modern ecosystem. So that's what we're working toward. So let's, I guess, take one step back and differentiate monolithic from MACH. Many of our customers have VL Web applications that were developed in the last 5 years, which is cool. They already have modern UXs and allow flexible deployment and scalability. But some of our customers have LANSA systems that were architected, a couple decades ago. These systems may be very capable, but they're limited by architecture. They're not just limited by user experience. In such cases, database access, business logic, and the screens, they're all blended into a single program. Let's call such programs monolithic. So by today's standards, this monolithic structure is old, it's rigid, it plays poorly with user expectations and cloud and partner systems, and it's impossible to take advantage of any third-party services that are new and cool. And lastly, most IT professionals under 40 probably don't understand any of it. Modern architecture is completely different, based on open standards that are well accepted by all. These standards allow for systems to be composed of services from various sources, snapped together like Lego bricks. If you've been around IT for decades, this may seem like a familiar story. Depending on how far back you go, you were exposed to client server, 2-tier, 3-tier, N-tier, OOD, SOA, enterprise service bus, etc. It's all contributed to where we are now, an ecosystem that unconditionally expects APIs and microservices. So why do we even care? So here's an analogy. Remember when, oh, sorry, I went too far. Remember when we used to have travel agents? We had, travel options that were limited, and we had curated packages by the providers. The travel agent would try to gather that up for us. And despite all of our efforts and all of their efforts, we probably ended up on a bus tour full of churches and museums, and maybe that's not exactly what we were after. Whereas, in a modern sort of microservices architecture approach for this, we'd have all of the providers having access to supply all of their tours and hospitality offerings. And then really all of that would be provided to Airbnb or Vrbo or Expedia or Booking.com or whatever interface somebody's wanting to use. So now all of a sudden the power is in the hands of the user, and all of the providers are just providing in a standard interface. And that, that takes away the need for a travel agent. So travel agents were all the rage. Anybody old enough realizes that commercial air travel, increased dramatically, and the travel agents had a really big boom until the web came around. And then all of a sudden you had all of these other ways where it was disruptive for the travel agent, and they were able to, users were able to find travel on their own. Same sort of thing happened with monolithic ERP systems. There was a big rise and buildup of these kinds of systems. And then around the year 2000, it started to decline, or at least the writing was on the wall for them to decline. And along came things like Salesforce, NetSuite, open source, etc. And that kind of made a dead end for 100,000 enterprises that are on monolithic legacy systems still today. But just like the web interrupted things in around 2000, now we have AI. And so we have a new way of doing things. So, again, this is just a look at why many organizations consider their legacy systems both a treasure and an anchor. They're very solid in terms of business functionality and stability, but they just don't play nicely in the modern ecosystem. So what are the options? If you're trying to get to the MACH cruiser out there, what are your options? You could do a rewrite project. Those tend to be large, expensive projects that are fairly high risk. You could try to find a cloud solution like a SaaS subscription that suits you. You could re-platform and just say, well, I want to keep my IBMI, but I'll just move to a hosted or cloud provider that has the IBMI in the cloud, which you might consider a win, at least in the short term. You could do a merger or acquisition. We've had clients do that, where they acquire or they are acquired in order to solve some of their issues. Or you can do a refactoring project. Again, those tend to be larger projects. Over the last 10 or 15 years, my team in LANSA Professional Services has helped our clients refactor their code into APIs. And these projects have been successful, but for large enterprise apps, it can take years and millions of dollars. Not everybody's going to be able to afford that kind of thing. So what else can be done in today's era? So, things have changed. We've got access to AI now, and we can refactor legacy code automatically. So that's why we want to introduce you to LAIR, Legacy AI Refactoring. Applause. So what does LAIR do? It analyzes the monolithic code that you may have. It provides metrics. It learns and applies templates as recipes. It explains and diagrams the current code that you have and its limitations. It estimates the cost to refactor in terms of LLM cost, and it actually does the refactoring for you. It generates code. So in this case, most of our clients want their legacy code to be converted to APIs. It self-evaluates and self-corrects, and it respects the training guidance that it's been given. And then ultimately, it stages the programs with the source saved to Git. It compiles the code as executables, and you're saving yourselves a lot of time. So we're going to hand over to Nick for a live demonstration of LAIR, which will be much more exciting than the stuff that I'm saying. Hey, Nick, over to you.
Thanks, Steve. Just switching views here, making sure I'm getting onto the right screen for you guys. Yeah, so good morning, everyone. Welcome to the LAIR demo. LAIR is a platform that where Steve said, we're developing to transform legacy RDML code to modern RDMLX components. You should see the homepage right now on the screen with links to 3 main workflow areas represented by these interactive icons. Excuse me, just one second. My screen is playing up on me. I'll be back there. Yeah, okay. We've got an analyze endpoint where LAIR will analyze and generate semantic and structural analysis of the LANSA code that you feed into it. We have a transformation endpoint. LAIR will execute the actual AI assisted code and transform the input into target RDMLX components. And we've got a configuration endpoint where you can manage what we think is a very highly configurable LAIR application and manage the settings and preferences. One of our goals when we did this was to make this as configurable as possible, and there is a complex configuration behind this whole thing. So this morning we'll be analyzing and transforming some legacy code. I'll show you what that looks like before we get started. I'm just going to switch here to my green screen application. And this is a function that's part of a major ERP application. It's a great application that's been used successfully by many companies for many years. And the unfortunate thing here is that all of the logic for the purchase order program you see, the display, the database, the business rules are all in one program. No separation of concerns. Like Steve talked about, it's just the nature of legacy code. It's monolithic. And this is an example of that. So I'm going to use this as an example for our transformation today, or an analysis and transformation. For those of you that are interested, I'll just quickly show you in the LANSA IDE. This is that program in the source code for that program in the IDE, the PUU-POF program, purchase order entry. So that's what we're working with in terms of what we're putting into the LAIR tool to generate our output. So we'll switch into the analyze page, and we've got 3 tabs here. We can run analysis, we have an analysis repository, and we have charts that we can see graphical output of our analysis. So we start off with running the analysis on that function that I just showed you. I will select the source code for that program from the LANSA repository. And you can see that the code is now loaded into the LAIR tool. This is the source code that's been loaded in. You can just review that real quick. And then we'll click on the Analyze button. You can also paste code into the analyzer, or you can select many source files for analysis at one time. And this will generate what you can see on the right-hand side of the screen right now. In the single analysis, we get this analysis on the right-hand side. If you were running a multiple analysis, you wouldn't see this. It would just be written to the database as each analysis was completed. We've called an AI assistant here to get a semantic analysis of the code, and that has sent us a little text analysis of what it read in the input. It's told us the purpose of the code, the logic steps, the data flow, and the potential issues in the input code. You can see it's produced a nice little summary of the purpose of the program. It manages purchase order header, line item data, multi-file validation, currency conversion, shipment tracking, cross-geo, inventory, and purchasing models. So that's a really nice little summary of what this program is trying to do. And of course, logic steps, data flow, and potential issues, things you might want to look at before you even decide to, excuse me, transform this code. Excuse me. It also produces a full structural analysis, and the structural analysis is actually config driven, one of those configs that I told you about, to pull out the operations that we want to see from the source code. We've got count metrics for the number of lines of code, the number of subroutines, the number of lists, the number of call functions, how many BIFs are used in the program, things like that. We have structural information on the operations data. We can see the I/O operations here. We can see the tables that are used and the input fields and output fields. We can see details of the component. It tells us what we might be able to generate out of this input code in terms of LANSA components. We could generate a REST API or a web view of the data. The interface right now is a display of fields. It's got the function options and the subroutines and the BIFs and the variable definitions. It's got the structures, all of the structural information, the UI specification. There are 1, 2, 3, 4 displays in this input function. It's got some validation rules. It's got all the function keys. This input does not have action bar or text maps. It does not have any RDMLX components. A little summary here of total of 67 fields. One input and 18 output. Little calculation here there by the look at. I'm just making a note of that. And it's also got our navigation. We've got screens here that are listed. The screen IDs are listed, and the program calls that this program makes. It doesn't have much validation apparently, and it does use group bys. We give it a complexity score as well when we analyze it, and this is apparently a very complex program. Scores 20 on a scale of 20. The complexity score is also config driven. You can apply weights to the operations within the program and apply complexity values to those to get your complexity score. It also gives us an estimate of what it's going to take, or price-wise and token-wise, to transform this program into an RDMLX component. It tells us how many tokens it's going to take to do the transformation, and it gives us an estimated cost, about 34 cents, to transform this input program into a REST API. The REST API is used for the basis of this calculation. Template selection, we keep a history of all the transformations that we do, and as part of the analysis, we look in our template repository to see if there's anything that might match what we're trying to transform. And it tells us here, we've basically transformed this before. It found 100% match of a previously transformed version of this program. And so if we do a transformation on this program, it will reuse what it used in the first case because it had 100% match, and we've got 90% confidence it'll do it again. So that's the single analysis. And also I have to tell you that the analysis will be extended this week, and it will have a new feature that will detail business logic patterns that are found in the input program. So that's something to look forward to in the terms of the analysis. It's going to lay out all what we can identify as business logic patterns in the input program and add it to the analysis output. Okay, with the single analysis done, all analysis are written to a database table. We call it the analysis repository. And all of the results of those analysis are added to this repository. So you can see here I've got 4,825 analysis results that I've got in my database. And here's the last one that I did. I can go back and look at the history of that analysis. It will bring it up. And here basically you've got the same result as what you had in the single analysis. As I mentioned, if you do a batch analysis, you don't see that, but it's here in the database and you can come and see it after you've done your multiple input and look at each one of your analysis and see the results. You can also export those results to an HTML file. You could save that off, put it in an email, send it off to somebody, store it somebody, whatever you want to do. It will include all of the detail that's here in the analysis. We also have an AI assistant built into this view. The AI assistant is focused on this specific analysis. I can ask it questions. Let's ask it a question now. I'll say, I'm just going to copy something off my notepad here and put it in to the analysis. I'm going to say, what tables are used by this function? Now, this might seem a little redundant because the analysis we've got over here already tells us what tables are used by this function. But it's actually quite helpful because the AI will go back into our analysis and give us more of a semantic kind of an overview of that structural analysis that we've got. So it starts to break them out into, you know, the number of tables, the primary tables, the general ledger tables, the purchase order tables, the master tables. So we get a little more of a semantic view of that structural analysis, a little more information just by asking some more questions about the data that we've got stored in that analysis. And we can ask this any kind of question about the data in referencing this particular analysis. So that's a little AI assistant built in there as well. I'll close this specific analysis down, and you can see that I also have an AI assistant over here next to the database table that stores all the analysis. Again, this AI is focused on the database itself, and so you can ask questions of the whole database. Maybe I want to know the average lines of code. I will type that. I'll just say average lines of code. Don't have to be too specific because this AI is focused on this table, so it knows that if I say average lines of code, I'm referring to this table, and it will run off and it will produce this result along with a little display of the calculation that it did. So here you can see it says the average lines of codes is 164. This is within our analysis database, by the way. It's not in the LANSA repository, it's in the analysis database. So the average lines of code is 164, maximum lines of code is 1768. We have a program with 1 line of code, and we have 4,826 files that we looked at. Again, it gives us a semantic analysis over here as well, just some text and inviting us to ask for more information. Distribution of file sizes, how many small versus large, correlation between their lines of code and complexity. So you can ask these kinds of questions of the database, and the AI assistant will traverse that data in that database and give you those answers back. So again, lots of information on the analysis side of things, and we're going to add even more. In addition to the analysis repository being able to do on-demand analysis with an AI assistant, we have a charting tool in here, and we've added some graphical representation to the analysis repository with these charts. We use a tool called Mermaid within the LAIR tool, and we can come in here and generate charts. If I wanted to do a component dependency chart for the analysis that I just ran, I can come and find that program. Whoops, I fat fingered that. And there it is. It's given us the an analysis or a chart showing us the built-in functions that are being used, what programs are being called, and what tables are used. We can do that individually as well. I could just say I want to see the component tables, and there they are, or I could say I just want to see the call graph, and there's that. And I can also do things for what overall is in the analysis repository. So I know I've done an analysis which involves the purchase order header file. So I can come down here and we'll say, well, tell me about the purchase order header file. That's a bit hard to read, isn't it? But I'll just switch that over so we can see that a little better. So this is telling me that the PUT-PHP purchase order header file references all of these programs, or all of these programs reference it, if you want to put it that way. So within our analysis repository, it's looking up dependencies between that table and other components, and we can chart those things. We can also see BIF usage. If I want to see where the concat BIF is being used, it can go back into the analysis database and find all the places that the BIF that BIF is being used. you have your own user-defined BIFs, and you might want to know where, here's one, a UD error log, and we can go and see where a UDL error log is being used, that kind of thing. These charts can be saved as SVG or PNG files, and you can also output the Mermaid code that was used to generate these or renders these charts. In addition to the charts, we also have, or in addition to the Mermaid charts there, we also have statistical charts down here. Here we can see we've got 33,288 programs that are very complex. We can see we've got 1,242 programs that are very large. We've got 1,777 which are classified as small. We've got charts on source code metrics like the top 15 built-in functions that get used. Apparently get message description is used in a lot of places. Browse list structures, external calls, the SEL TFR program is being used in many, many places. Component references. This component is being referred to 9 times across the database. So all these charts that we've added in to show you the occurrences or the main occurrences of components and function definitions and input fields that you can come and look at for individual programs or for the whole database. So that's the chart side of things. And pretty much that's where we're at with analysis right now. As I mentioned, we are adding new analysis output for business rules that we can identify in the input program, and those will be added to the LAIR tool. Okay, so that's the analysis side of things. Now we have actual transformations, and I can go to the transformation part of LAIR here, and again, we've got this interface where we have a tab to say run transformation and look at the transformation repository. As I described the analysis repository, the transformation repository is a sister table that records all the transformations that are run in LAIR. So from the run transformation tab, we can specify what output components we want to generate from our input file. We've been very focused on generating LANSA REST API services for the input, but we have also been working on generating LANSA web UIs, LANSA data service, and other things as well. But our focus has mainly been on REST APIs at this point in time. We do have the ability to do these other things, but maybe not the complexity that we now have built in to build REST APIs. Anyway, we can email generated files if you'd like, but that's not the default option. The default option in the system is to write the output into a folder that the LANSA repository has access to. And when you do that, when you write that output into that folder, you can go to the IDE and you can see that code in the LANSA IDE immediately. And you can verify the code, compile it, or just see if any errors were generated by the transformation, go back and make corrections, that kind of thing. So that's the default methodology, is to stick it into a folder that the LANSA IDE can see, and then you can go from here to the LANSA IDE and view the results of your transformation immediately. So again, I'm going to select from the LANSA repository the transformation that I want to run. I'll pick that program that I picked earlier, and again, the source code is loaded, and you can see the source code here. I will not bore you with actually running this transformation. I'll show you in a second, but we can select single, we can paste content, or we can transform multiple programs at one time. The reason I won't bore you with the transformation is that basically you're going to see a spinning circle here when we run the transformation, and that will take anywhere from, it depends on the complexity of the input, but anywhere from 30 seconds to a minute or two, depending on how much work the AI assistant, the LLM, has to do the transformation. So I don't want to waste time in this presentation with waiting on the transformation to finish. I've previously done this transformation, and you can see it here in the transformation repository. PUU-POF is right here as the last thing I transformed. And again, it's been stored in the database. We can look at the information about the transformation. This is what would have shown up on the screen if I had run it. We would see what was the file information for the input, the information about the LLM provider, the cost of the transformation, and any validation errors or truncations or things of that nature. And there's a little input of the source context. We have an AI assistant here, which what we can ask questions about. So let me see. Let's say what's the average cost? Actually, that's no good. I'm on a specific transformation here, so that's not really a good question to ask. Let's ask that. Let's say, tell me about this. And I'm going to leave it at that. I don't have to say, tell me about this transformation, because it's looking at this transformation. So I just said, tell me about this. And it's going to go and look at the details that were stored in the database about this transformation. And we have to just give it a minute to think, thinking. So boring looking at something think, isn't it?
Fortunately, I never do that, Nick, so we're good.
Okay, well, anyway, it's going to come back with the analysis. There it is. So yeah, it's telling us all about this analysis, this specific analysis. You know, it's telling us what was attempted. It was telling us that it had a high complexity, telling us what the key business operations were in this transformation. It says why it failed or what it might have failed. It has template mismatch opportunities and things like that. So we can analyze the transformation and see what might have happened, right? That specific transformation. In addition, you can analyze the whole database. This would be a better place to ask about the average cost, because this is looking at the whole 777 transformations that I've made, and will come back and tell us the average cost that it has in this database for all the transformations that were run. So again, the average cost is about 8 cents. The highest cost was about 38 cents. The minimum cost was a little less than a penny. And the total cost so far of 770 transformations is $68, or 775 apparently. Oh, I know what that is. Yeah, okay, I'll get that fixed. Yeah, and so, and again, the textual analysis that says a little bit about why or what these average costs are made up of. Do you want to see the cost by LLM? Do you want to see the cost by component type? Do you want to see the cost by success level? So all these questions you can ask of the database built into LAIR. How are we doing for time, Steve?
I think we're good. We're 34 minutes in. Okay.
So again, we have analyzed the database just like we did with analysis. This is great for keeping track of where your analysis exercise or your transformation exercise is going, or how it's progressing. You'll notice on this table here, I've got quality and success level. So these are important things that you can record about your transformations and go back and measure what your success level is, or whether your failure level. There will be failures, and you can go back and analyze what your success level is or your failure level is. You can see most of the transformations we're doing. I'm concentrating on REST APIs. Here's ones that failed, and I could go back and analyze this transformation and find out why it failed, make corrections, and run it again. Okay, so we've analyzed it, and now we need to see the proof in the pudding, as it were. Just by the way, the business logic patterns that I mentioned being added to the analysis, they will also be added to the transformation logic as well, to enhance the output and get as much business logic transferred into the new program, the transform program, as we possibly can from the input. So we're actually adding that business logic pattern knowledge to the transformation as well when we add it to the analysis. So what I'm going to do now, as I said, is proof in the pudding. We will switch back to the LANSA IDE, and I'll just switch my object that I'm working with here. And if I actually, before I do that, let me just go back to the transformation, and I'll bring up the detail, and you can see down here that my output was PUUPOF API server module. So when I go to the LANSA IDE and look at the PUUPOF API, here's the code that was generated by the transformation system. You can see that it's stamped. This is the date that I generated this with, the 25th, a couple of days ago. You can see there's comments. You can see that we've got our endpoints for the API using HTTP. We've got a get for the purchase order header. We've got a create for the purchase order header. We've got a delete for the purchase order header. Excuse me. We've got a get for a specific, for a range of purchase order headers. This is just selecting to build a list. So all this code was generated from the API, from the LAIR tool, and generated this REST API. So that is now in the LANSA repository, and it can be compiled automatically as it's put in here, or you can compile it yourself. I can check to see if there's any errors in here after it was generated. So here you can see this is the go-to tab. If there were any errors, they'd be listed here. There were no errors. I can compile this program. Like I said, you could do that automatically if you want. I'm just doing it manually here for the sake of the demonstration. So I'm compiling it, and it will compile. I won't wait too long on that, but we will switch now to some further proof of the pudding. One of the things we do when we're working with APIs is we try to test them as soon as they're up and running. We use a tool called Postman to do that testing. I'm just going to clear this page here. So when I built this API, I put it up onto our IBM. So this URL that you see here is pointing to our IBM, where I put that REST API that was generated by the LAIR tool. And so now I'm going to call that routine, the get all PUT PHPs, get all the header records in the API on the IBM. And so it called that API on the IBM API, and passed me back a JSON file with all the, or actually the first 20 records is what it's been programmed to pass back. But you can see it's passed back the details of the first 20 records in the purchase order header file from the IBM, and this is just for testing purposes so that we know that the thing is functioning good and we're getting the result that we expected. So that's one way we use of testing. And in addition to that, we went a little bit further. I'm going to go back to my web browser. Well, there's the compile completed. You can see here that it's got a completed status, which means the program compiled okay. So our transformation and generation of this REST API was successful. I'll just drop that down, go back to my web browser here. We went a little bit further on this example that we want to show you, and we created a web page that uses the API that was generated. So just like in the Postman test that I showed you a moment ago, we wrote this this HTML page which calls the API on the IBM, and it returns that JSON file to the HTML page, and we use that JSON file. You can see it says here loaded wrote 20 records. We use that JSON file that was returned from the IBM to build this list of records in the HTML in a user interface, as it were. Excuse me, just 1 second. I have to roll my text along here. So we've got some things in here. We can see we're online. We can refresh the page. We can create a new record. We can look at an existing record. We can do deletes. We can do updates. I won't go into all that business because it's all quite straightforward. But this was just an HTML page that we have hooked up to our REST API that was generated by LAIR and gives us a practical use of that API. We threw it together real quick, like I said, to give you an idea of how the REST API can be used. It can be used in HTML like this, or it can be used with React or with Vue. For intercompany programs, you can have your REST API support intercompany data exchange, even inter-business data sharing from your API. REST APIs are available and capable of doing all of that. And this API was generated in just a few minutes by our LAIR platform for Legacy AI for refactoring. That's it for me, Steve.
Okay, thanks, Nick. That's awesome. Give me 1 second, I'll take over. Okay. There we go. Okay, so yeah, I mean, you can see that there's a lot of power here. A lot of it is the LAIR product itself. A lot of it is the LLM that underlines LAIR. What's been really necessary was to corral the power of AI. If you just go off and maybe, you know, out of curiosity, you've tried to have an LLM write some lines of code, it's, you know, it tends to hallucinate and get off track and so on. So as we've gradually built this product, we've learned all the lessons of how to use the LLM APIs that are available and build an entire pipeline that supports consistency and good quality without sacrificing the speed. So yeah, just moving on from that, you know, LAIR was inspired by market demand for refactoring legacy LANSA apps into MACH architectures. We were in the same boat a year ago, needing to refactor our e-commerce solution, which is called LANSA Commerce Edition. So what we did was we created LANSA Composable Commerce, which is API first, and it has a React JavaScript front end. This is the same front end used by Meta, Microsoft, Airbnb, Netflix, Tesla, Shopify, Uber, etc. So it's a powerful way of doing things. So now this LANSA Composable Commerce proven e-commerce solution has a MACH architecture and instantly benefits from the modern ecosystem. Our customers can tap into whatever ERP or CMS or search or whatever else that they might have in their ecosystem already, or that they find most attractive. And you know, our composable commerce solution will be able to take advantage of those things because of the architecture. So as you saw in Nick's demonstration, LAIR can refactor a 2,000 line monolithic program to APIs in seconds and for pennies, literally. I think, what was it, 33 cents or something like that for a 2,000 line program. LAIR is definitely best used on mid to large size applications. If you've only got, you know, 2 LANSA programs in your world, then I don't think refactoring things manually would scare you off. But otherwise, if you've got hundreds or thousands of LANSA programs, you know, that can take a lot of time. We've done tests where we've had, you know, trained LANSA developers refactor an application, and a given function that's quite complex, it might take about 40 hours to refactor. And you know, LAIR did it in, I forget the number, but less than a minute anyway. Yeah, LAIR did the same thing, and arguably with really, really good consistency compared to what a human programmer would do. You know, either one can make mistakes, but given enough training and guidance, LAIR is really, really good at this stuff. So we've got an aggressive roadmap for LAIR. I mean, AI makes everything easier, right? So LAIR will soon generate front-end code to match the generated APIs. So Nick showed you how he used Postman or created a little front end for testing. We don't see any reason why LAIR can't do that for you. It's got all of the inputs for the APIs. It can generate, a front end, whether that be in LANSA or React or Vue or just plain JavaScript. After we address LANSA, we expect to consider RPG or other old languages, whatever the market needs. With the LAIR infrastructure and the power of the LLMs, absorbing another language becomes a lot easier. We're also planning to make LAIR into a cloud service, like a SaaS service, for those that would prefer to deal with it that way. So, as I said, my team's helped with many refactoring projects long before AI and LAIR were a thing. With LAIR, we do a lot of with LAIR, we do pilot projects to configure and train LAIR on the target system. Then we run LAIR across the full code base, and then it's time to test the results. So as you can see, there's a lot of effort that's bypassed or expedited thanks to LAIR. And the money that we're talking, the 34 cents or whatever it is, $68 for 775 monolithic programs that were converted with LAIR, it's negligible. $68 for 700 programs, it's a joke. So it's really, really powerful to add this tool to your tool belt. So just some more information about the pilot project. This is definitely a critical exercise. We need to install and configure and hook up to our client's Git repository, and different LLMs can be used. We've had success, frankly, with all of them. But let's say our client wants to use OpenAI, then that's cool. We'll work with their account and hook that up. LAIR will analyze your code, provide all sorts of metrics across whatever sampling of code you want us to look at, and then with you we'll create a pilot project, meaning choosing a subset of the code and focus LAIR on that. There is going to need to be some training and correction. It's an iterative process for a couple days. And then we'll throw on a React or Vue front end. Some of our clients are comfortable in developing React front ends. Others have used Postman. Others don't. It's kind of all new to them. So that's fine. We'll help with that process to show that the APIs are working and help draw them out in a visual way. We'll provide findings and recommendations that would be used to go after the full scale conversion of 1,000 LANSA programs or whatever it is that you have. We'll also provide project planning assistance. It's not just magical that you throw LAIR at this and suddenly you've got a completely converted application with APIs and front ends and so on. There's still other parts of the project that need to be considered. There's the financial aspects, there's onboarding of users and so on. I mean, LAIR helps with a lot of it, but there's still a need for people in the mix. And at the end of the pilot project, we'll present our findings and provide some knowledge transfer. And then after that, it's up to our client. Do they want us to see through to the end, the full conversion, or do they want to pick up LAIR and run with the project? That's up to them at that point. So yeah, I mean, we're selling LAIR as an annual subscription, and there's a discount for early adopters. This is a brand new solution for LANSA. We need some good success stories. So there's a really big discount for early adopters that are willing to share their success story. And we hope that we've got some questions from you. You can put some questions into the questions panel of GoToMeeting, and we'll get to that as soon as possible. If you want to be taken back to Nick's demonstration of LAIR, you can ask questions of LAIR itself. You saw that Nick could type in any old questions and it came up with answers. There might be something there that you would find interesting. I'm not sure. So I'm just looking at questions here. Sorry, not used to this interface. Okay. Hi, Nick and Steve. Can I choose the LLM in the transportation such as Claude? Thank you.
Yes, the answer is yes. We have, at the moment, we say we can support 6 AI models, that being OpenAI, ChatGPT, Google. I can't remember them all off the top of my head, but yeah, we've got up to 6 right now, and I believe that that number can be extended. So yes, we support various LLM models.
Right. Yeah, I mean, some of our clients maybe are standardized on one or the other. I'm not sure. But in any case,
there's a question here that from Carl Mainville. It says, is a Git repository required? Yes, the answer to that is yes. The LANSA version control system is leveraged in order to run LAIR. So you need to have that LANSA Git repository, the LANSA version control system in place to use LAIR.
there's a question about, will the recording of this webinar be shared? Yes, it will. I can't tell you exactly the mechanism for that, but anybody that's registered, I'm sure will get an email with a link to the recording if you want to share it with others or review it, or heck, have an AI summarize it for you. Nick, I'm not seeing a whole lot of questions coming up here, so do you have a better view of this?
I have a few here. I'll go through what I can here. Is it possible to convert bad procedural RDMX code to good written RDMLX code? Not something we have focused on. I'm sorry, I don't know how to pronounce the name. I think it's Zesis. Not something we've concentrated on, Zesis, but yes, the answer is yes. We would have to do a pilot to build out the configuration to achieve what you're asking, but I believe the answer is yes. We could refactor RDMLX into better RDMLX. I've got a question here on the learning curve. I think the learning curve is probably around about a week for somebody to sit down, excuse me, and learn how to use LAIR and understand the configurations that we're feeding LAIR to get the results that we're getting.
Right, and the pilot project includes, a week of knowledge transfer at the end of it.
Right. There's a question about privacy with OpenAI. The answer is we believe it is private. We are not storing anything in OpenAI. We are passing prompts and it is returning answers to questions using an API, and OpenAI tells us that they do not store that data. And we also have a parameter set on our OpenAI account which tells them not to do that.
There's a question, I'm seeing different questions from yours, I guess, Nick. One of the questions here, it says, did it create an API for placing an order? So I'm guessing they're talking about when you did your transformation, did it create an API for placing an order? I know you've done transformations of programs among your 700 or whatever that placed an order. Do you want to talk about that for a sec?
That's a tough question to answer, because in effect it did create an API that will allow you to create an order. The API contains all the CRUD operations that you need to maintain the purchase order header. So it has a select routine, it has a create routine, it has a fetch routine, it has a delete routine. So you can call into that API and create a purchase order header. So the logic, the user interface logic is not in there, just the database logic. And you can, like I did in the Postman example, where I called the API to get the records back, you can call the API to create a record. So you pass it the data that you want to insert, and you call the create endpoint, and it will insert the data to the database. So in effect, yes, but if you understand the MACH architecture, it's not. It provides the ability to create orders. It doesn't actually create orders. Does that make sense?
Yep, I think so. I mean, basically, whatever the function did when it was monolithic, all of that screen logic that it included is replaced by the receipt of information via the API. And then when the API is called, whatever functionality the monolithic application had in terms of doing I/O and, in this case, let's say placing an order, all of that logic remains the same. It's basically untouched. So it'll do whatever it did. It's just it's getting rid of all of the screens and allowing you to interface via APIs.
Yeah, REST APIs don't include user interface, so you have to remember that. Yeah. Yep. I've got a question here about where the source is pulled from. As I said a moment ago, you need to have a LANSA version control installation in order to access the source from the LANSA version control system. We do not look into the LANSA repository. We use the Git repository that's associated with the LANSA repository to get the source code.
Right. So hopefully most of our customers at this point have transitioned to use Git. There's a lot of power and consistency in that. And if they haven't, then I guess let us know. We can help you get there. We've helped, I don't know, hundreds of clients switch to Jira or GitLab or GitHub or Microsoft DevOps or whatever, and start working with Git. And of course, LANSA works with Git. So we've helped a lot of our clients with that. But yeah, I mean, if you're moving into this world of using AI to be generating code, I'd like to think that you're either already on Git or you're interested in a Git repo.
Yeah, and remember that the LANSA IDE is connected to that Git repo and fetches the source code from there and displays it in the IDE. So there is that connection between the existing LANSA IDE and the Git repository. So when we write a transformation back into that Git repository, it's available in the LANSA IDE. Let me see if I can grab another couple of questions here. Have we got time?
Yeah, I mean, we can probably go. Let me just interrupt for 1 second, Nick, and just say that for folks that are interested in getting started, they can contact their LANSA sales representative or email sales@lansa.com. But I think we can continue on and take some additional questions, Nick, for those that have them.
Yeah, there's quite a list on my screen. There's a question here about, see if I can go through these in some kind of order. So there's a question about security and sensitive information handling. LANSA REST APIs support JWT tokens, and of course you can run your web server across HTTPS, or build any security you want into the application. LAIR's not involved in determining what security or any kind of encryption stuff. It's just transforming code, and what you put in that code is up to you. What applications can be refactored with LAIR? At the moment, we're really concentrating on legacy RDML applications like green screen applications or web event applications. Are the REST APIs created in RDMLX? Yes, that's the only way you can create REST APIs in LANSA is in RDMLX. And the power of the program flows transformed into the REST APIs. That's the whole subject of LAIR, how it does the work. We analyze the input, we extract what we know is needed by to create a REST API, and we go ahead and transform that data that you gave us in the input code to build that REST API. And the REST API that we build is based on a template. So if you have some custom requirement in the output, we can adjust the template to include that custom requirement in the output. Performance or scalability, it's kind of an unknown right now, but performance has been very good. This LAIR runs on a PC, so you know, whatever the bigger the PC, the more performance and scalability you've got. So yeah, kind of an open question right now. We still have to do some scalability testing, but you know, the more horsepower you've got, the more output you'll get. What version of LANSA is required? Version 15, I think, is the minimum to run a VCS. And that would allow you to run LAIR and generate code back into the LANSA repository.
But obviously, we'd prefer clients be on 16 if you know, if they're able. Exactly.
If I wrote an application where I didn't use commit rollback and filer operations, can LAIR suggest how to modify? As I said, it's a template-based system, so you can actually build the template that you want to see. And if you want to put commits and rollbacks in your template, they will be in the output. So yes, you could generate output with new logic, such as commit rollback logic, if you wanted. One of the things we did was we used a template that included additional components within the logic of the REST API, like you know, looking up logging. Logging is a good example. Logging traffic on the REST API. We created a reusable part that can do logging from REST APIs, and we put a reference to that reusable part in our template. So every REST API we generated had a reference to that template and called that, or had a reference to that reusable part and called that REST reusable part as part of the logic. And that was retained in the output program because it was in the template.
So part of the reason why we need to do a pilot project with our clients is because there is definitely some, you know, learning. There's some training that LAIR needs to go through. There is sort of this template refinement. We've converted or transformed, you know, hundreds or thousands of programs, but we haven't transformed yours. So we have to be able to put LAIR to it, allow it to do its best. And then we have to refine some of its training in order to be able to do what works for you. You know, we've given it lots of variability and thrown some strange things at it, and it still does really well. So we have pretty good confidence that it's going to be able to handle any kind of, you know, system, enterprise system or whatever that's monolithic, that's developed in LANSA, and different flavors of LANSA and so on. But you know, what we would encourage you to do is contact us, maybe give us a tour of your specific application, you know, how it's architected, and then we can help you understand, or we will basically just blurt out, hey, this looks like an awesome fit, or no, it doesn't, or yes, it does, but it'll take some additional training, or maybe we'll need to add a feature to LAIR for you. We're going to be led by where the where the market takes us with LAIR. We have had requests for converting non-LANSA things, whether it be RPG or COBOL or sign-on or whatever. And there's no reason for us to believe that any of that would be challenging. I mean, if you think about it, LLMs are amazing at translating from one language to another. So, you know, given the right pipeline around it, the LLMs will be able to do that. The value that LAIR brings is in terms of the pipeline that's been created and the many trials that we've done for, you know, for months and months, or I guess a better part of a year, and all of the experience that we've built up with that. So we're interested in what your system is today and where it is that you want to take it. And I guess just challenge us with that, and we'll let you know if we think that LAIR is a good fit. Are there any other questions, Nick?
There are a few more questions. Do we want to keep going?
Go for it. Yep, go for it.
Somebody asks about the how we calculate complexity. The complexity rating is user configured. So you give weights to the operations within the input source code, and those weights are assigned during the structural analysis. So you can configure how you want the complexity to be measured based on the configuration. Right now, I've got a system that uses a scale of 20, and I assign various weights in the configuration to database lookups, things like that, and then that's what generates the complexity. What else have we got? What kind of LLM monthly plan is required? Well, it kind of depends on how much traffic you want to put through. The LLMs usually sell, or their subscriptions based on usage. So they give you a subscription that says you can use 100 tokens a month, for example. And once you hit that 100 tokens a month, you have to pay some more. It is a API call, so they have plans in place where you can say, let's say you buy $25 worth of tokens, and once you use up your $25 worth of tokens, you can automatically buy another $25 worth of tokens, or you can manually go and buy another set of tokens. So, you know, if you set a limit on how many tokens you want to use, you can stick to that limit. Or if you want to just keep going, you can automatically refresh the amount of the tokens each month, or when they are used up.
It's almost negligible, though, honestly. I mean, in terms of the scale of a project, you know, in what Nick showed you there, 775 or 777 or whatever it was, programs were modified, and they had an average of 170 lines of code or whatever it was. And that in total has cost $67 of LLM time. I don't think we have a customer out there that would choke on that and find that difficult. So I think that the use of the LLM, yes, it'll be, you know, you need to set up an account and so on, but it's going to be such a small factor in the success of the project in terms of the cost. I think it's basically negligible.
One of the question here from Omar Monroy, is it possible to use LAIR for web development from LANSA using server modules? That is, for LAIR to give us recommendations for code optimization. Absolutely, yes. That the analysis that we are doing and will continue to enhance will allow you to get those recommendations and generate new code if that's what you want to do. Does it work with old VLF frameworks? Again, we're concentrating on 5250 and web event, but there's no reason why we can't extend the application to read RDMLX and generate REST APIs for things like the VLF framework. We answered the question about the version. We want to see on version 15 or later, preferably version 16. There's a comment more than a question here. It says, you know, this can provide a lot of value for allowing users to leverage existing code. while using front-end devs to build out which front end they want to use. That's absolutely true. Thank you for that comment.
Yeah, I mean, that's really where the market seems to be going, is that you know, you've got all of this extremely valuable functionality in your back end, but there's so much demand right now to interact, I should say integrate with third parties in partnership, or to bolt on some kind of a mobile application that needs to be able to touch the back end system. It's just nonstop, and it's very difficult if you don't have the right architecture to be able to take advantage of this. So what ends up happening is that there's some competing group at the client or at the company that will go and develop from scratch some other solution or whatever, when there's so much value in the enterprise solution that's you know been agilely adapting to market demands for that company for decades. You know, it's been able to support the business for decades. There's got to be a lot of good stuff in it, and exposing that via APIs just takes away one of the biggest headaches. This isn't to say that you can't use a product like Axes or something like that, or develop in LANSA to bolt a front end to an existing application, or develop a mobile application or whatever. Certainly you can. But if you've got a large enterprise system and you want to very quickly get to the stage of being able to have every part of it wrapped in APIs, so that you can develop a new front end in LANSA or React or Vue or whatever front end you want, or you want it to be able to interact and integrate with a third-party front end, then I would suggest that this is probably the way to go. It's going to be much more efficient than any other method that we've been exposed to. And again, like, the efficiency is from something that takes 40 hours to refactor down to seconds or a minute. It's almost laughable. And this is after the training, of course. You still need to train it. You still need to guide it. But that's a really small part of an overall project, assuming you have more than just a handful of monolithic LANSA functions to refactor.
I think that's there's one question at the end. I don't know if you can see it, Steve. It's about licensing, and
I don't know why I can't see any of these questions that you're seeing. I saw two and then they disappeared, so I don't know what's going on. Sorry, what's the question about licensing?
I'll read the question. You can tackle it. As this is a refactoring solution, I trust there is no need for a perm license, as you only need to refactor, re-engineer one time. Could just be a requirement for 6, 12, or 18 months, depending on how many legacy application programs exist at each company.
Okay, yeah, I mean, that's completely fair. We're going to make it a subscription license for now, and you may be right that after the first year, there's no reason to re-up for a second year if you've transformed your applications and you're done. Then yeah, you wouldn't need it. I don't know the situation that the person that's asking the question has. Some of our clients have multiple applications written in LANSA, and maybe they're going to focus on one at a time rather than converting them all very, very quickly, and then you know, having to have the business test all of them at once. It may be that they want to take a per application approach, where they'll allow LAIR to convert their application to APIs, write the front end, or merge with whatever front end they have, or have us write it, whichever. And then they'll have the business test it and take it live. Maybe then they'll turn to another application in a second year. I'm not really sure. But the subscription approach gives you flexibility to do that. As I mentioned, we may consider putting this as a SaaS service, and we're still figuring out exactly what metrics we would use. Would we charge per line of code? Would we charge per analysis? There's a lot of things we haven't figured out yet related to that. That's another reason why we want to go with the subscription license, because it gives us some flexibility at LANSA to price things appropriately down the road. But I mean, we think LAIR has incredible value, especially if somebody's got lots of LANSA stuff that they need to turn from monolithic to APIs. I think it's got absolutely enormous value. I wish we had it 5 or 10 years ago, but you know, AI didn't exist then. So we're here now, and we think we can help a lot of clients re-architect. So that was it, Nick. Any other questions?
I think that's it.
Okay, I guess we'll end there. Thanks again for everyone attending. I don't see any additional questions on my side either, but yeah, so contact sales@lansa.com or your sales rep, and please do throw things at us. Give us challenges and let us know what type of applications you have and where it is you want to move to. And I have a pretty good feeling that LAIR is going to be able to handle it, but I guess we'll see. Thanks, everyone. Take care.
Thank you.